ARC Junkies presents Weld Wednesday with AWS. Brought to you by the American Welding Society. And now your host, Jason Becker.
All right, ladies and gentlemen, joining me today is Rob Murray, all the way from Maryland. Rob, we met up, we haven't actually met up, but we got introduced through a mutual friend, John Douglas, who works with the AWS Foundation, and I was talking to him while I was at the Welding Summit in Houston, Texas, and he's like, man, you got to talk to my buddy. He's, serves on this code committee, but he does a lot of really cool stuff with, the world of underwater welding. And I get a lot of students I get a lot of people that reach out to me on Instagram and stuff like that, and they want to know all about underwater welding. And it looks like you have a very highly technical background in the world of underwater welding. So I wanted to kind of get your perspective. You also serve on one of the AWS code committees, so that's kind of the connection for the Weld Wednesday. But welcome to the show. I look forward to kind of breaking down, talking about your history and kind of diving deep, pun intended, about your background and your history when it comes to underwater welding and inspection and some of the cool stuff that you've done in that arena.
Great, yeah, pleasure being here, Jason. Hopefully I can add some useful comments.
Oh, I'm sure you can. So how did you get started in the world of underwater welding?
I've always had an interest in welding ever since I was a young kid, but when I got out of college, I got a job at Westinghouse Oceanic. I went in there. They had still had diving programs going on, because two things I enjoy doing my whole life and been blessed with my career, I kept doing it, was diving and welding. And eventually the two came together. And that happened when I went to work for the Navy in the office of the director of salvage and diving. So I first went to work there on the diving side. I was running some diving programs, mostly equipment acquisition and developing new diving equipment and whatnot. And on the other side of the house, the salvage side, they had another division that was called underwater ship husbandry. And they would do underwater ship repair, change props, do damage control. And they were doing welding, but the welding was mostly temporary repairs. It could be patch jobs, enough to keep the ship going, complete its mission. But when they got to dry dock, it was all cut out and redone. And the director over there approached me once, because I had somewhat of a welding background, said, hey, we really want to advance our underwater welding. Would you be interested? I'm like, man, yeah, welding, diving, the two together now. So, I got over there and started putting what I learned in welding with proper processes and techniques and formalizing how to do the repairs and get them to where they were considered permanent repairs. Especially with the wet welding, which is hard. You don't do wet welding, or we do dry chamber welding. In dry chamber welding, you usually achieve, surface quality weld. So those repairs would normally get considered permanent. The wet ones that would not. Mm-hmm. So we got to where we could do certain repairs on the ship's wet welding, and it'd be classified as permanent, and the ship didn't have to worry about it next dry docking.
Yeah, that was one of the things that caught me by surprise. I thought that, because I went down to Ocean Corp just to do a little bit of underwater welding, for like a day. And that's one of the things that they told us is like, the majority of the time they would rather bring the object or the ship, up to like dry dock or up on top of the deck of the ship to be able to perform the weld, just because you can't get the same weld quality. So anything that gets welded underwater, it's like emergency or temporary, or it's not, it's not a critical component, that it's going to be a long-term in-service weld. A lot of times it's temporary or Band-Aid or something small of something like that, and they try to bring everything up to dry conditions to get better welds, or like you said, they'll put the I guess what they call a bell, like a submersible, like a dry dry chamber and everything down there. So it was pretty interesting to learn that, because I'd always thought you can do it underwater just as well as you can up top, but it wasn't until I went through that one day seminar or whatever that they kind of bursted my bubble on that one.
Yeah, so it's not all. Certain welds you can't do wet and get considered permanent. Like whole plate replacement and whatnot. You're just not going to get the strength out of the weld. There's going to be too many impurities in there. But things like bilge keel repairs, certain plating on rudders and whatnot. That before they wouldn't even let the ship run, 6 months that way where, we got the quality of the welds down to where it was okay.
Mm-hmm.
But there are companies now, Phoenix is one, Miami Divers that have qualified Class A weld to AWS D3.6, which is considered as good as a surface weld.
Really? And I would imagine they're using the SMAW process?
What process?
The shielded metal arc welding or stick welding?
Oh, yeah. I'm sorry, I didn't catch. Yeah, it's all stick welding. When you do it wet, it's all stick welding.
Right.
The Russians tried to do a flex core welder back in the early 90s. It just didn't work. Too many moving parts.
That would make sense.
Yeah. But yeah, stick's been the way to go. In dry chamber, anything goes. I mean, you could do MIG, TIG, but mostly it's stick.
Now, how do they set the dry chambers up? Because I would imagine that's kind of a pretty big ordeal, setting that up dry conditions underneath the water. I mean, how do you guys build these things around the different structures or pipes or components or parts that, you're welding on down there?
Yeah, so usually on the chamber, you're open bottom and open at the top. So the top part is somewhat flanged. So you can change that top part out, and you have to cut it to contour to whatever you're working on, like a ship hull. So you have to cut it, contour it, and then you put rubber padding on it to help seal it. And then those things are hogged up against the hull. So usually you weld some pad eyes to the hull plate, and then you use come-alongs and you just hog this thing up nice and tight. And then you start blowing it down with air from the surface.
You just pressurize it and it pushes all the water and stuff out.
Yeah. So you pressurize it, a couple PSI over bottom pressure, get the water out of it, and you can set up shop in there.
That's pretty slick. And then you just kind of dive down there in your scuba gear and pop in and change over, and you're good to go.
Yeah, well, surface slide. Nobody works in scuba, but surface slide and get up in there. And
that was one of the questions I was going to have for you. Is why don't they use like self-contained underwater breathing apparatus as opposed to the hoses and the dive helmets and everything that we typically see for underwater welding?
A lot of it's safety. All right, so it's, you want to be tethered. You got to have communications. Most of the guys now have cameras on their helmets, so topside always sees what's going on. If something happens to the guy, you can pull them up by the umbilical. In scuba, you're too isolated.
Okay.
Things can go wrong, and they do go wrong. I mean, surface flight, you got an endless amount of air coming to you, no matter what.
That makes sense. And then it's all like oxygen, or do you guys do like, for different depths, do you have different mixes and everything? Because I know like when like deep water scuba diving, they'll use like a trimix or something like that. Or like nitrox?
Yeah, so it depends on your depth, right? So typically for ship repair, you're 50 feet or less, so you're just going to be breathing air, standard air that you're breathing right now. Go through a compressor, gets pumped down to you. If you're beyond 30 feet, you got to start watching how much time you spend down there. Otherwise, you have to do decompression. When you get in the deeper waters, past 100 feet or so, 150 feet, you start thinking about going on mixed gas just to give you longer bottom times. And then if you're going real deep, you get into saturation diving.
Now, what's saturation diving?
Saturation diving, it goes on your body can only absorb so much nitrogen out of whatever your breathing gas is. So no matter what depth you're at, you're going to get saturated with nitrogen. So if I'm at 300 feet, I can only absorb so much nitrogen. Nitrogen is what damages you if it causes the bends. So if you stay at pressure, then you can work as long as you want. And so what they do is pressurize you on the surface to 300 feet, send you down in a capsule. You do your work at 300 feet, and you can stay down there all day long. When you're done with your shift, you come back up in a pressurized capsule and you go into a chamber. And you stay in that chamber, you live in that chamber at the same depth, right? And every day you just keep going to work. And you can do that forever, And then at the end, you do your decompression.
Oh, wow.
So for general rule of thumb is for every 100 feet you're in sat, you spend roughly a day in decompression. So if you're at 300 foot sat dive, you're roughly going to spend 3 days in decompression.
Damn, that's.
But you do it at the end of the job.
Okay, so that gives you a little bit more, time on your tools, so to speak.
Yeah, and it's more economic for for the companies to run you that way instead of pulling everybody up every couple hours and you have to keep switching out people.
And those decompression tanks, they're not they're not very big, comfortable, spacious areas. And I guess there's like a lot of I don't know, limitations and stuff. Like there's not a whole lot you can do while you're in there, right?
No, you have a little rack you can lay in, and you can watch some videos, and you're sharing a little head somewhere in the corner somewhere. And yeah, they're tight, they're hot, they're stinky.
Catch up on sleep and reading.
That's it, yeah.
Okay. Now I guess you've also changing gears a little bit. I guess you've done some friction stir welding underwater as well.
Yeah, friction stir welding. So yeah, I started that project with the Navy back in the early '90s, and we took a pneumatic. First one we did with a pneumatic friction stud welder, which was originally built by TRW. Then it went to Ramstud. But we used it in the water and it worked fine. And we went through a whole program of qualifying studs, and we welded. I welded about 400 and some sets of studs and went through all kinds of testing. We actually even did Sharpies on them, which you usually don't do on studs, but just to see how effective it was underwater. And we did it on different materials. We did HY80, DH36, A36, and it worked great. We're welding, did all the studs, 1/2-inch studs. And then we, problem with the pneumatic one is after it comes out of water, it's a lot of maintenance. You got to strip it down completely because it floods out. So then we did a civil program and we developed a hydraulic unit to use, which welded great. And we welded up to 1-inch studs. It was not depth sensitive at all. Hydraulics run anywhere, so.
As long as you got pressure.
We actually did as long as you got pressure, yep. But the process is a great process. It hasn't really taken off much, especially in the offshore industry, other than maybe using it for attached anodes. The Navy's bringing it back online again because there is a lot of work for it, especially with the LCS class ships, which are aluminum, which, not much you could do with welding aluminum underwater, but you can friction weld aluminum studs to it and whatnot, and mainly for maintenance and damage control.
Okay. Now, how are those new aluminum ships working out? I mean, do you have any experience with them? Because I've heard they had some issues. Like it all looked good on paper and it was going to work out in theory, but we all know how that kind of goes once you get the project underway and
yeah,
throw it in the drink. How are they panning out?
To me, I'm not involved that much with it, but from what I hear, not very well because they're hard to maintain.
Mm-hmm.
They got to be dry docked a lot. Aluminum and salt water.
Yeah, you wouldn't think those two would go together.
Not that well, and it's hard to really put a good coating on aluminum. So, you get a lot of crevice corrosion creating places and yeah. So, steel ships to me are the only way to go.
Yeah. I want to say I read an article in one of the Lincoln magazines that came out because I guess they were using Lincoln wire on those aluminum ships. But that was the last I've heard of it, and I've heard a couple things in passing from different people that they're not working out, that well.
Yeah, it turned out to be, I think, a maintenance nightmare.
Yeah. So now, how long have you
it's
been?
a new class, so they'll have to work their way through it.
Right. Now, how long have you been involved in the world of underwater welding, especially with like government contracts?
I started around 1990 when I got involved in underwater welding.
Okay. And did you go through like a Navy training school to learn how to, do the underwater welding, or did you go to, I guess like one of the underwater welding schools, like regular civilians and stuff go through?
Well, what it did is where I worked, with the Office of Salvage and Diving, our diving services contract with Oceaneering at the time, Oceaneering International, which is a huge diving company. And they provide most of the underwater welders. And that's where, I got my experience was from them. And then I, kind of worked and established training some of the Navy divers in welding, to put together a curriculum, and it's just in the water practice. And I mean, if you can weld on the surface, you can weld in the water if you can get comfortable diving.
Mm-hmm. I know that getting out of position with that stuff's pretty difficult. We tried that a can't remember the name of the electrodes we were using, but I ran it in the 2F fine, but then we tried going vertical, and it was not working well. And I think somebody told us, they're like, "Oh, try running it downhill." And I was like, "Well, that goes against everything that I know as a welder to run downhill." But I guess, heat input's not it's not as big of an issue on the surface because, you're underwater, so you're not building up a whole lot of heat anyway.
And the problem with going welding up is all your gases are going into your weld puddle.
Yeah, it's all over the place. It looked
pretty, and you can't see what you're doing.
It was gnarly.
So it's vertical down.
Yeah, you kind of got to weld by feel when you're doing that stuff, because I tried watching it the whole time, and it's hard enough to see because it was cloudy in the tank. But then, and then on top of that, you got your lens, that kind of flips down. So you're trying to weld through that. But then as it's burning off, you see all the bubbles and everything popping up. So you really can't see your puddle. So you got to do it by braille. You just put the rod in there and just kind of go by feel and, hope it's going in there right.
By feel and sound.
Mm-hmm.
So as you get it right in, you got to put a little pressure in there, and you're basically dragging the rod, and you listen, by sound, you can tell, how your arc is doing, if, you're long arcing or short arcing too much. But yeah, it's just, you're in the blind doing it.
Yeah, it's a lot of fun. Now, I guess you did you hold a record for the deepest wet weld at 2,000 feet?
Yeah, so I didn't actually do the weld, although I was hoping I would be able to. But yeah, that was done for submarine rescue, and it came about a weird way. So back, I guess 2000, when the Russian submarine Kursk sank, and they really didn't have any capability of rescuing those people at the time. So the U.S. Navy did some lessons learned from the Kursk, like how could we have done something? And they had a meeting, and I happened to be walking past the conference room just as the meeting was ending, and one of the individuals in there had I guess AAA personality. Just told the guys, "There's nothing we could have done. We don't have any welding capabilities. It's to 350 feet." So I got dragged in after this guy left to go, "Hey, we were told this." He goes, "That true?" I go, "Hell no." I go, "You can weld to 350 feet, not a problem." I go, "Where the problem comes in for submarine rescue is the logistics involved, because you'd have to do a dry chamber. So again, you have to fabricate the chambers, you got to mobilize all that, and try and establish everything on site within a limited amount of time. Because with submarine rescue, just like with a mine rescue, coal mine rescue, if you're not on site within 3 days starting your rescue, the chances of getting survivors are slim. So like in the Kursk, those guys, they know they live, 5 or 6 days. So you had to be there day 3 at the latest starting, and you wouldn't be able to do that with dry chamber. But, as I told them, I said with friction welding, friction stud welding, you'd be able to do it with an ROV. So in U.S. submarines and most NATO country submarines, on their escape hatch, there was a connection point where you run a cable down, which your submarine rescue chamber will come down on and guides the chamber down, so it goes right over top of the escape chamber, so you can get it sealed and go. Russian submarines don't have that, and they weren't NATO in the NATO countries. So that was the problem with the Kursk. There's no way of getting a rescue chamber on it. So what I proposed at the time was use friction stud welding with an ROV, go down, shoot a pattern or studs, bolt on, clamp device, and put your hog down cable on it. Well, also at that time in submarine rescue, they just got a contract going for ADS suits, which are 1 atmosphere suits for the Navy, and it justified it for submarine rescue. The only problem was they didn't have a real mission. I mean, they can go down to 2,000 feet in the suit, but they had no job to do once they got down there. So the director, who I was, telling how you could do the welding, goes, "I need you to formalize this, come up with a plan, come up with a cost estimate, but forget the ROV. I want you to do it with an ADS, because I got to save my program." So I'm like, okay, put a little different twist in. I know it's easy with the ROV because you got hydraulics, you got everything right there. So I went back, and I called a friend of mine, oceaneer, a guy named Jack Couch, who was a really sharp guy, real good underwater welder. And started telling me what I needed to do. Well, just so happens he was getting ready to call me because he had a job where he thought the only way he could do it was with friction stud welding. And he was trying to see if he can get me to help him, engineer some type of friction stud weld for his job. So we kind of combined our efforts, and we went down. We did some feasibility trials using their ADS suit, which is, they call it a WASP, and then their tank, and we able to fit up hydraulic welder to it, and went down. We started shooting some studs, patterns of studs, and I was like, okay, this is going to work. So then I went back and actually formalized the project for sub rescue. So I did it through a SBIR, Small Business Initiative Research Program, where you get money from the government, and it was a couple-year program, but we eventually got everything designed so we can go and do the test at 2,000 feet. And the biggest part of it was being able to do a hot tap, because that's the first thing you got to do in the rescue, submarine rescue, or even in the mines. You got to start getting life support to the guys.
Yeah, you got to, because air's limited in there. You got to.
Yeah, you got to breach through the hole, man. Start getting gases in there. So we developed a hot tap stud. So the 1-inch stud that was hollow, and we developed a stuffing tube for it, so we could drill through it, close it off, and get gases in there, or take a gas sample in there, because you need to know first thing what's going on inside there, what type of atmosphere you have in there. So we actually did the test down in Panama City at the experimental dive unit. They have an ocean simulator, which is a huge tank that presses down, actually pressed down 2,500 feet.
Damn.
So we put put the WASP suit in there and went down and welded the studs at 2,000 feet. And they passed. I would say they passed code, because they passed the mill standard 1689 for studs, because we had to do tensile tests on it, and they passed the tensile test.
That's really cool.
Yeah, that was a fun project. It was one of those, you can't do that type of job,
Yeah, that's one of those things where they tell you, like, oh yeah, it can't be done, and you're like, okay,
we're
gonna figure out a way to do it. Now,
that's what drives me. Whenever somebody tells me you can't do that, oh yeah.
Yeah, watch this. So now, have they actually put that process, that application into use since it was developed?
It never got to use it. It came close. The first time was with when the San Francisco hit this seamount underwater and had damage, and they weren't sure what was going on, so they asked us to get a kit ready to go, and then it didn't need it. And the second time was the Dolphin, which was a research submarine, and it had a battery fire. So everybody had to abandon ship, because it was just, hydrogen sulfide gas was building up. And then they didn't know how we're going to open these hatches, or we need to take a gas sample before we do anything. So again, we're getting ready to mobilize to go out and, do our penetration through the hull with the studs that we developed, so we get a gas sample. Then shipyard, Puget figured another way of getting a gas sample. So never got to use it.
Oh, that sucks. Now, what are some of the gases that you're afraid of running into down there?
Well, actually, like batteries, when they catch on fire, have issues, you get hydrogen sulfide building up. So that's a very toxic gas. The other thing you need, you just got to find out what your O2 level is, what your CO2 level is. It's going to tell you a lot. If it's 100% CO2, well, no way to survive in that.
Mm-hmm. And then I would imagine once you guys figure out, exactly what type of gas you're dealing with, you can start pumping in the correct stuff to, I guess, dissipate or.
Yeah, start purging somehow. Yeah, purge the atmosphere.
Yeah. Now, so once you start pumping those gases in, is there a way for that system on the inside to off gas some of the whatever's in their atmosphere that they're actually breathing?
Yeah, you got to. That's another avenue that we really didn't get to finish it. But as you're pumping gases in, you got to be able to get gases out. So at pressure, that's a tough thing.
Mm-hmm.
So you have to be able to pump the gas out and up to the surface.
Yeah, I would imagine that kind of be difficult. You would think that they might, come up with some sort of monitor, like I guess like a air monitor, like an oxygen monitor, kind of like what we have up, topside. You got like a what we would call a sniffer, and it would kind of, measure all that stuff, but have it like wireless to where it could feed back, in real time, just kind of like through some sort of means to be able to tell them exactly, hey, this is what we're dealing with on the inside, so you don't have to poke a hole in there and get a sample that way.
Yeah, if everything's, if the sub's just down and everybody's still functioning and all equipment's functioning, you can do that.
Okay.
You have means of doing that through water communication. It's just that when, you have no communications in there. You don't know if people are alive. You don't know what's going on. So that's when you have to go into these extremes. But most of the time you're going to have good communications. If stuff just went down and it's not imploded and it's just sank for unknown reason, but everybody's still functioning. Yeah.
Yeah, I think that'd be one job in the Navy that I would not want to do is be on a submarine. You're just floating around there in the bottom of the ocean in a tin can and can't see nothing, and you're out there for 6-8 months at a time. That doesn't sound like a good time to me, especially for anybody that's claustrophobic. Yeah, it's got to be boring.
Or it's like sitting in an airplane.
Yeah.
Nonstop.
Airplane with no wings sitting at the bottom of the ocean, just bebopping around.
And hey, you know what? Nothing changes. You never know. You lose track of day and night because the lighting's the same.
Yeah, man. So did you get a chance to hang out and go offshore and hang out on a submarine?
I have, yeah.
How long did you do?
I did 30 days once, and that was more than enough.
Oh, damn. Yeah, that'd be
That's my longest trip.
Yeah.
I tell you, when we came back in, I was the first guy out of that hatch.
I imagine so. Now, what was it that led you to having to do 30 days on a submarine?
I had to go out do some equipment testing.
Okay, so
we're out for a while.
Were you guys able to weld underwater while you were down there?
Oh, we weren't doing any welding. This was other type of equipment.
Okay.
Yeah. So like I say, sometimes I get to do welding. Sometimes I get to do diving. Sometimes it's just underwater type of equipment. But
okay.
Welding and diving is the one I like doing the most.
So what's some of the coolest projects that you worked on while you're a civilian contractor working for the Navy that you're able to talk about? Because I know you've got some top secret clearances and stuff. So there's probably a lot you can't talk about. But what's some of the cool stuff that you were able to do that you're allowed to elaborate on?
Yeah, kind of some nice challenges. Again, a lot of them were you won't be able to do that. And one of them was I was in San Diego for a meeting so there was a military sea lift ship that was in dry dock. They just bought these ships from Maersk, and they're doing a conversion on them, turn them into kind of ro-ro ships for strategic deployments, and actually to store all kind of Army equipment. These things would be deployed or staged around the world in case the Army needs to be somewhere real quick. So when they built these ships, the weight increased, or when they made the conversion on them, the weight increased quite a bit. So they were not able to float out of the dry dock. They had to lift the stern of the ship to get it over the sill. So what the shipyard did is they came up with this pontoon scheme. So they welded these pontoons to the bottom of the hull at the stern, and they just connected them with I-beams that were welded to the hull. And then as they flooded the dry dock, the stern was raised up a little bit, and these things came out. The stern was coming out of dry dock, and then the divers went, and these are shipyard divers, commercial shipyard divers, went and flooded the pontoons to sink the stern so the bow could get over the sill of the dry dock. Well, they didn't have a plan or didn't really think about it, so they just started opening valves. Well, these pontoons started floating. They built up a harmonic, and they were just doing this, moving up and down. And the welds broke loose from the hull, so as the ship's sliding out of dry dock, pontoons would go down. They come up with these I-beams or punching holes in the bottom of the ship.
Oh, damn.
So they, did some quick patchwork inside, pumped it out, got it floating. And then they get into this, whose fault is it? The Navy's fault? Is it the contractor's fault? So Navy being self-insured, or the government being self-insured, the shipyard out in San Diego said, hey, we'll put it back in dry dock and fix this, but it's going to be $15 million. So I knew the guy who was running that project, and I knew him for quite a few years. And so he contacted me. He goes, hey, I know this is reaching out there. He goes, here's what I got, And he showed me the damages. He goes, they want $15 million to put it in dock and fix it. He goes, any way you can do this underwater? I'm like, I think I can, so started planning on it. And what it took was there were 5 areas that had to be cut out hull plates. And the sections of the hull plates that were cut out were 7 feet by 6 feet lengths. And I told everyone I'm going to do, man, I got to cut out these big plates. And I'm like, you can't do that. I go, hey, it sank once, so what's another sinking? Now I can do this here. So he goes, well, what's the estimate? I go, you know, probably 600K. He's like, well, I don't think you can do it, but for that price, it's worth the investment. So, we went out there and I went out with a couple guys from Oceaneering and we started went to a sister ship so we can start looking at the areas and seeing, how we could do this. And we came up with building these huge inductors. And an inductor was like a chamber, but what we did was they would have to go where the damage area was and they get sucked up so that when you cut the whole plate out, you're not getting any water in. What we had to do is put the replacement plate inside these inductors because there's no way we're toting them through the ship because we're way down in the bilges. I mean, way down. It took, I want to say it takes almost 30 minutes from the weather deck to get down to where the damage areas were. And you're going through these really tight spaces.
Yeah, that's just personnel, not all the equipment you got to bring and materials and all that stuff.
Yeah. So, we designed these inductors and, we went to work and, we did this job in 5 weeks. But it was a pucker factor because when we made those first cuts and we have an inductor and we measure so many times, we set the inductor underneath on the outside. Now we're inside down in the bilges and we got to cut out the damaged plate. And if you're off by an inch, water's coming in. So one of the things we did, because we weren't sure how good we were, so we're basically down in a enclosed space. So we brought down a bunch of scuba jugs and had them around just in case we flooded the space. We can all grab a regulator and a jug and find our way out of there. So luckily that never had to happen, but we did have to use those jugs and we'll get to that. But yeah, we ended up, cutting these plates out, bringing up the plate from outside and welding them in. And we did that in 5 different places. But the funny thing is being down so deep, we had to have air pumped down to us, big blowers on the deck, just bringing fresh air down to us, And one of the guys on the job, we always had a tech writer on the job. And he would, come around, take pictures and, keep track of what we're doing so he could write a nice report at the end. Well, we're down there and I just got done emptying, I think, the final welds and I was feeling a little tired. So I'm sitting on my little 5-gallon bucket. And I was like, man, I just got to close my eyes for a while. Well, apparently we all passed out. Somebody had turned off the blowers up top. So we all succumbed to, basically carbon dioxide, and we all fell asleep down there. But a tech writer comes down, take pictures, and he sees us and he figures we're just sleeping on the job. So he's taking pictures of us, and he goes, I'm going to have a good time with this. Then you realize we ain't waking up. So this guy was sharp. I mean, he was a diver. He opened every one of those bottles and put one right by each one of us. And man, he was slapping us and hitting us and he saved us,
Damn.
But we didn't flood the ship,
Well, I mean, that's a plus, but you almost died doing it. Jeez. Did you find out what was the cause of them, the blowers not working?
Yeah, a bunch of workers on the ship topside, just unplugged them because they needed a power outlet.
Yeah, they just wanted to charge their cell phone.
Yeah. But, that's one of the things you kept quiet because there's like a ocean no-no,
Yeah. I've had that happen on job sites running mag drills overhead and somebody decides they want to unplug your extension cord so they can plug their microwave in for lunch or something and mag drill falls and hits you in the hand. But yeah, not as bad as, having your supplied oxygen cut off.
And then, when I went out initially to do assessment of the job, I went out for, just 2 days, an overnight trip, take a look, see what come up with. While I was out there, I get a phone call. You got to go. I can't tell you where I had to go and I can't tell you the ship, but you have to go. And it's South Pacific. So I was like, what? Yeah, you got to be there tomorrow. So, I went with what I had, one pair of underpants, and another shirt. And I flew over there and there's a submarine that got in trouble in another country. And what happened is they went into an anchorage where they're allowed nuclear submarine. And all the senior officers took liberty, went into town, were partying, and they just left one junior officer and skeleton crew on the sub. Well, where they were in these straits, the tide change is really significant. And the submarine started dragging its anchor. Well, the junior officer on board starts panicking. He really didn't know what to do. So he tries bringing the reactor online. Now, submarines have what's known as a SPM, a secondary propulsion motor, which is electric. So as long as they're running their diesel generator, you could run this thing. And that's all he had to put that down. He could use that, put that ship anywhere he wanted. Well, he wanted to nuke the reactor back online, which takes a long time to do, going through all the procedures. Well, meanwhile, they drug their anchor 7 miles, and they get into an area where it's just fossil ship anchorage, no nuclear ships. And by the time he got the reactor online, he starts up and he just starts moving forward. Well, he got tangled on the anchor road of a surface ship. And so he's doesn't know what's going on. So he's just giving it power, and the surface ship starts to take a big lift. So they panic, and they go out and they cut their anchor road, which is all chain, right? Just they realize what's happening with the sub's doing this, and they cut the chain, and it just goes down. And chains are used for cutting metal, heavy steel sometimes. So this thing was on the hedral, which is comes off the stern of the sub at about a 30-degree angle, which holds the countermeasures on the 688 submarines. So it just cuts about 3 feet into it and then just wraps around it. And now they're anchored by their anchor.
Shit.
And so this country's freaking out because they got this nuclear submarine where it's not supposed to be. So it ends up going over to a Navy base by another country that said, yeah, you can come into our dock and use it. So I sent over there to try and figure this mess out. And so I get on the phone, I'm talking back to a guy in the Pentagon. He goes, what's up? He goes, what do you need? I go, yeah, we can get this untangled, we get this fixed, we get this guy operational, because he had to be somewhere. I mean, he had an operational commitment that he had to make. It's a big political thing. And I go, and I need at least 2 weeks to do this. He goes, you got 6 days, and he hangs up the phone. I'm like, what? So I'm just there, me and 2 other guys, and go, man, I gotta get a crew. So I brought some Navy divers in from Guam, got some commercial divers in from Australia. We put together this crew, and we just worked night and day, around the clock. And we built this thing. I had to do some trading off with an Australian ship that was in a dry dock next to us, just happened to be over that port and to get material. So, it's funny, T-shirts go a long way. Hey, man, I got this T-shirt. You got any, I need some A36 steel. I got plenty of it. Go 2 T-shirts. All right.
Damn, you lucked out on that.
Yeah. So we get this thing all built together, and we had to put the countermeasures back on, right? So they're explosives, right? And they're sitting over in a warehouse, and all of a sudden I get this message: all stop. You can't load the countermeasures because there's no EOD, explosive ordnance guy, around that can handle this. I'm like, I have a hazmat license. I have explosive training for my CDL. You gotta go send it to me. So I fax that. He goes, approved.
Damn.
You are on-site EOD guy. So I'm going now. I have to load, move the countermeasures from the warehouse, get them over to the crane, so we get them in the water and load them on. So I'm driving the forklift. I got everything grounded properly. Get over to the crane. I'm grounded to the crane, and you got the crane operator there, and tell him lift it up and move it over. He gets it up in the air, and all of a sudden this storm comes out of nowhere, lightning everywhere. He jumps out of the crane. He's freaking out, and everybody's running. And I'm thinking, man, this thing's just hanging in the middle of the air. It's like if I jump in the crane and just dump the stuff in the water. Then we got hooked up, and we got everything 100% back together, working perfect. And so we did it in, I didn't make my 6 days. It was 6 days and 4 hours.
That's pretty damn impressive regardless. I mean, you told him a timeline of 2 weeks. He says you got 6 days.
Yeah, so it was, impossible. But that was probably the most challenging, the most rewarding, to be able to do that and do something that was mission critical, get these guys back in operation so they can go do what they had to do. And they did. They did this is 96, so figure out what was going on over in the world in 1996, and they did some good stuff.
Damn. So in addition to your underwater welding and stuff, you also do underwater inspection. So other than like visual testing, what are the other types of testing that you can do underwater?
Well, magnetic particle inspection is the most common one.
I wanted to ask you about that because I just started a mag particle class for AS&T, and it was kind of cut short by the hurricane that ripped through here. But how do you do mag particle under the water?
Okay, actually, it's actually easier. Now, the only thing you got to watch out for is, your MT, your yoke, it's still AC yoke, 110 volts. So you have to have, really nice GFI at the head end of it, and you got to do good inspections of your cable because 110 will kill you in a heartbeat in the water. Okay, but other than that, it's great. So what's nice about it is, the powder is the same, same powder. We just mix it with a solution, water solution, and you put it like in a ketchup squeeze bottle, and you just squeeze it out, and the particles will suspend in the water. Right, so only those that are needed get attracted to the indication. The rest just float away. So you don't have this mess there. You're like, you don't have to come back with your blower and go, blow your particles away to see where the indication is. If it's there, it's gonna, because the particles, when you squeeze it on, they'll stay suspended in front of your area for quite a while, but only be attracted to where your leakage is.
Okay, so it works better underwater than it does on land.
It does. I say it does.
And then you don't have to worry about your hands looking red when you're done. You get dye everywhere.
Yeah, you don't get that.
That's pretty slick. I never, because I never given that a thought. I was like, well, I would imagine you could do ultrasonic testing. If you keep everything waterproof, is that another type of testing that they do?
Yeah. So ultrasonic testing we've done. You keep your remote unit on the surface, and you just run a longer lead, and you're just running your probe in the water.
So you got somebody else reading the output.
Yes, yeah. So you have somebody else reading the output, and you got to establish a procedure for it because you got a long lead and you're gonna have line loss. So all that has to be factored in and calibrated properly and whatnot. But yeah, it works good. It's tough because the guy on the surface is trying to guide the guy with the probe. And that gets a little confusing. Mm-hmm. We also do RT underwater. So, we put the film in a cassette, waterproof cassette, and that would get mounted on the outside underwater. And then you come inside with your source and shoot through the hole. And then you bring the film up and process it as normal.
Huh. Pretty neat stuff. Now, so how did you get involved with the American Welding Society doing all this?
Well, when I took over the underwater welding program for the Navy, the only document we had to use at the time was D3.6 because the Navy had not developed, one of their mil specs for underwater welding, which later became known as NSTM 074. So, it was recommended that I get on that committee to, get the Navy's input into it so the document could be more usable for the Navy. And at that time, it was when I first got in committee, it's noticed that things change over the years, but it was mostly driven by the oil companies. So you had representatives from every major oil company was on a committee because they're the ones that doing a lot of offshore work at the time, and they wanted these documents to meet their needs. Mm-hmm. And then you had, the diving contractors there were probably the three of the best. You had Oceaneering, Global, Subsea, and they had representatives, really smart guys, really smart engineers. So back in the 90s, I said we had a great committee. We got a lot of stuff really moving forward and did a lot of good work. Over the years, it's kind of flipped. Now I'm looking at it, it's less of the customers on a committee and more of the diving contractors on a committee. So we get a lot more arguments going on now because everybody's like, I want it this way for me, the way I work.
Healthy debates.
Yeah. But it's all good. It's all good. I think the committee is, for underwater well, I think we've done a lot, because it's being recognized internationally. So the international standards are basically mirroring the 3.6 standard.
Yeah, it's one document that I haven't had a chance to become familiar with. I do a lot of the like D11, D12, D13, all those. But yeah, nothing for underwater. I'd be interested in checking that out and seeing some of the differences because it's literally a completely different world underwater than what you're used to up surface side. So a lot of things you can get away with up top, you can't get away with down there.
Yeah, so if you look at it, you'll see a lot of familiarity with D11 in there. With the testing, because again, we have a couple different classes of welds. We have Class A, Class B, Class C. So a Class A weld kind of meet the same criteria as you would find in D11. Class B weld for less critical applications, where, wet welding is going to give you what you need. Where, in a Class A weld, usually you're going to have to go to a dry chamber to meet those qualities.
And then, like you said, with dry chamber, I mean, you typically is like TIG welding probably the primary process, stick and TIG in there, or do you guys use any sort of wire fed applications at all?
It's primarily stick, done TIG, for doing some pipe welding and stuff that needed to be done. But yeah, mostly it's just stick welding, and for the Navy side, we're usually using, a 7018 rod. So you treat it all the same, it comes out of the oven, you get the same time constraints on it as you would anywhere else. And, you treat it when you're working in the chamber, just like on the surface.
Yeah. So there's once you're doing like a dry chamber weld, it's literally just like being in a shop, but it's smaller. It's like working in a phone booth. I would imagine.
Yeah. We got preheats going all the time because our requirement in the Navy is you have to maintain a minimum of 125 degrees in there.
Oh yeah, that makes sense.
Yeah, just to keep the moisture out, so it gets hot, and man, we did a job in Bahrain a couple of years ago, dry chamber, and air temperature outside was 120 in the shade, water temperature was 95, and in the chamber, these guys couldn't spend much time in there. It's just miserable. You just could not get cool anywhere.
Yeah, I would imagine like those little air conditioning vests and all that stuff probably wouldn't help at all, or the ones you put the ice packs and all.
Yeah, it's just the logistics of doing it. We tried all that stuff, and it's extra hoses, and then you're getting you can't move. You got all this extra crap on you, and
yeah, that doesn't sound like a lot of fun. I bet it pays pretty well, though, I would imagine.
It doesn't. It doesn't. So the guys that are really got the experience, that have been out there doing this for a while, they make good money, make a good living. And a lot of people think, "Oh, I'm going to be on the Underwater Welding, I'm going to make millions." Doesn't work that way. They make a good living. Mm-hmm. They're not working every day, but they do make a damn good living. The problem is getting into it, right? So nobody's going to come out of a dive school and go, "Here, you're not over well to go to work." They start out normally as a tender for a couple of years, which is the lowest job on a dive crew. So you're the guy just doing grunt work, and they gradually work you into getting into the water and doing work because, it's money. They're not going to put somebody in the water who's not going to do it right because it's going to cost money.
Yeah, especially somebody fresh out of school.
Yeah, it's a very long apprenticeship, and a lot of people don't want to wait. Especially nowadays, they just, if I can't make my, $100 and some $1,000 a year now, I'm not doing it. They don't want to go through the ropes of learning how to do it properly.
That seems like a lot of people. I mean, and I think that just goes from like welding schools, all the probably trade schools in general. Is as soon as the student graduates from school, they're like, "All right, I'm ready. I need to make $40 an hour now." And it's like, no. You need to go over there and get on that grinder and prep all this material and, pop all these holes and run all these bolts in and, get this material. You might be able to do some tack up and fit up and everything, but you got to start off at the bottom. It's like anything else in any other career, same thing as going to chef school. You're not going to walk out and walk into a Michelin restaurant and just start, being a sous chef. I mean, you got to start at the bottom.
Yeah. And that's a mindset that we need to get back to, because even, when I went to work for Westinghouse, right, I had an engineering degree. I went there as a manufacturing engineer. And you know what it stuck me? Machine shop. You're going to be there for a while. You're going to learn this job from the bottom up. And that was great. I had no problem with that.
Mm-hmm. And that's kind of the way, it should be in most industries. I'm a huge fan of apprenticeships because, you've got to start at the bottom. You can't just walk in there after, a couple months of schooling of anything and just walk in and start performing the work because you don't have any experience. You understand the theory. You've got some, hands-on experience, but you don't have any experience with the work. You've got experience with the technique and the fundamentals, but like where that application is going to be, you have no experience whatsoever. So you need to follow somebody around and do the minuscule task for them and kind of understand the importance of the minuscule tasks that you're doing, because you're not doing work just for the sake of doing it, or for busy work. You're doing it because it's part of the process, and it's typically a very important part of the process. You got to learn that aspect before you go on to the next step.
Yeah, it's I don't know. It's strange. I just don't understand why people don't want to do it. I mean, to me, when you come out of school, I don't care whether it's a trade school, college, whatever. All that is shows that you're trainable.
Mm-hmm. Yeah, you're able
now
to
go
learn.
learn.
Yeah, you're able to learn.
Now go learn. And I got concerns with the future, man. If we don't get back to that, nobody's going to do it. I mean, I look at I go out on jobs now. The average age on a dive site is in their 40s. 20 years ago, most people in their 40s were starting to look at other careers. Getting out of the underwater welding and diving and looking at other stuff to do. But there's nobody coming in. I mean, it's very few. You see, a gung-ho 20-some-year-old kid that, wants to learn this and go.
Yeah. It's usually, because I taught for quite a while. I taught for about 7 years, and it's usually maybe 2 to 3 students, out of a class of 13 to 15 that are like really in it, and like they've got the drive and the motivation to do it. Everybody else is kind of, checking the boxes, doing the bare minimum to get by. And, and some of them, I mean, there's hope for some of them. They don't realize it until they get out in industry that, oh shit, like I need to tighten up and, start putting a little bit more effort and stuff in. So, I mean, you might be getting 50% of a class, that's coming out and actually getting after it. But I mean, the numbers are so far behind in every industry right now. You're going to play a heck trying to catch up.
Yeah. It's, I don't know. Scary.
Yeah, it is. I'm hoping it takes a turn for the better. I mean, and the cool thing is that, there's a lot of trade schools popping up. There's a lot of interest, from the next generation to get into it. We just got to have the right educators and the right people in there, and not slack off on the standards. I think that's one of the biggest things is, everybody wants to do that whole participation trophy type stuff. And it's like, you can't have that in especially in our type of industry. You gotta have your head on a swivel. You got to be there to put in the work, and it's going to be physically and mentally demanding, and it's going to take a lot of effort.
Yeah, you got to get back into the schools, into the high schools where it was mandatory. You took these type of classes, the trade classes. Where now it's like, oh, you're not academically doing well. You're going to go to the special school and learn a trade.
Yep. I remember back in my high school, we had woodwork, we had automotive. I mean, there was welding. All kinds of good stuff. And like now they've taken a lot of that stuff out because, oh, it's too expensive. Well, it's not. I mean, the schools are just underfunded.
Yeah, but you got to get their kids interested in it. And that's the age that you get them interested in doing this stuff.
Yeah.
And that's what I did. My career, I've had a blessed career. I can't complain about it. But I never chased money. I did what I wanted to do. Mm-hmm. And fortunately, the money followed. But I kept doing what I wanted, what I enjoyed doing, stuff I learned to do when I was in high school, or even earlier, and just stay with it, and for some reason, doors just kept opening for me. I never planned anything. I didn't have this goal. I'm going to be doing underwater welding, or I'm going to be doing this. It's just all of a sudden the door had opened. I go through it. It's like, wow, I like doing this, but it all kept me in what I enjoyed: diving, welding, and other stuff.
Yeah, but I think you still have to put in the effort and everything. Like, doors aren't just going to open for you. I mean, you got to have a passion and a drive for what you're doing, and, be able to show up every day. Work ethics are a huge part of it, like soft skills, employability skills, because like nobody's just going to walk up to on a job site or in a shop and just, provide somebody an opportunity that hasn't earned it. So like I would say every door that's open for you, you've earned, to be able to knock on that door and somebody to open up on the other side.
Yeah, no, I agree. I mean, you had the experience, you had what somebody's looking for, a lot of it you hit on work ethics.
That's
give
the
an honest
thing.
day's work.
It's hard to teach. Yeah, honest day's work for an honest day's pay. Be able to look the foreman or the boss man or whoever in the eye on payday when you get that paycheck. Well, now it's direct deposited, but I remember that's one of the things that one of the old timers I worked for, man, he would bust his ass, and he was an older guy, and I was like, hey, let me get that for you. Let me do that. Because he was older, and like, coming up through, different trades, like you try to take care of the older guys, the guys that have been doing this for 20, 30 years, and they're like, nope, I got it. I want to be able to look the boss man in the eye on Friday when I get my paycheck. Damn.
Yeah.
And that
Yeah,
stuff like that stuck with me.
Yeah, exactly. I mean, that's drilled into me very hard, even going to school. So, I started out, I went to community college. I mean, I got out of high school, I had no goals, right? So I said, I'll go to community college. And I took electrical engineering. Took me 4 years to get a 2-year degree, but, I was working, I had to pay my way through school. And then I said, it's not bad. And I decided to go on to the University of Maryland, try and get a 4-year degree. So I applied for electrical engineering at Maryland and had to go see an advisor. And he goes, yeah, we'll bring you in. He goes, but we're not taking any of your credits from the community college. I'm like, huh? He goes, nope, we don't accept credits from the community college yet.
Oh, wow.
He goes, we'll take some of the course and if you had some of your English, some of your other stuff, but your physics, your chemistry, all that stuff, not transferring. And I'm like, man, I'm paying my way through school. I mean, I'm diving, doing some commercial work. I'm playing music and driving trucks. And I'm like, that ain't going to work for me. And I think he saw my disappointment. He goes, well, I think we got a program for you. And a lot was based on my grade point average from community college, which wasn't stellar. I mean, not proud of it. It was 1.999. And after a little abrasion, they finally rounded up to 2.0 and let me graduate. But, again, I was working 2 jobs, sleeping in class because, I'd work all night.
Mm-hmm.
But anyway, so they put me in this program. It's called Industrial Technology. And in there, you could choose where you want to concentrate. You can get into like fire investigation and whatnot, industrial hygiene and manufacturing engineering. So I'm like, hey, what's in manufacturing engineering? He goes, well, you got to take a lot of machine shop, 2 semesters of that. You're going to get in other shop classes and you're going to take 2 semesters of welding. I said, man, I'm in. That was the best thing because to be in the program, they took 30 students a year. You were on probation the whole time. So you couldn't, play sports, couldn't be in fraternities or any of that. And you had to have a job and the company had to sponsor you. They weren't paying for you, but they had to guarantee that they would make sure you were working so many hours. And, you'd go to school full-time, work part-time, then you flip it. You'd be working full-time, going to school part-time. So the requirement they had was you had to go for, a company like GE or General Motors or Westinghouse, and they give you a list of companies, go talk to these people. Well, this is back in the 70s. The minimum wage was $1.70 an hour. I'm like, this ain't gonna work for me. So, I was kind of driving for Allied Van Lines at the time, part-time. So I went and talked to the agent I worked for. I go, hey, I want to go to take these classes, go to school here. I need a sponsor. He goes, yeah, we'll sponsor you. My advisor hated that. Truck driver, that ain't what we want here. I go, meets the requirements. He said I had to work for a company more than 50 people. I had to have a business structure, finance department, all this. It's there.
Mm-hmm.
And it was great. I mean, it was that discipline that you got to work, and you got to earn it.
Yeah. That sounds like a pretty good opportunity. I wish there was more schools like that set up, along that same lines to where they do that. It sounds very similar to the like the German apprenticeship program, where they like even with the Canadian Welding Bureau, you got to go in and as part of your training, there's X amount of OJT hours that you have to accumulate while you're there, and then you kind of flip flop. You'll do school up front, a little bit of work, and then the last 2 terms or last couple of years, you'll do full time work and then part time school.
Yeah, that's exactly what it is. And unfortunately, Maryland got rid of that, shortly after I graduated, because I think, again, people started like, I don't want to be doing that.
Yeah.
I don't want to work with my hands. Go to school.
But
I want to be in a fraternity. I want to party in school.
I think a lot more people want to work with their hands than we actually, we think about. Because I mean, when you sit down and I used to when I taught welding, it was at post-secondary or like adult vocational type people, and a lot of them, they had previous degrees. They'd done the college thing, and they're like, that wasn't for me. And it's like, why didn't you get into trade sooner? Well, it wasn't an option. I never had that available to me. So like I was pushed into getting this degree, and I don't want to do anything with it. And then I found this place, and I want to take welding, or I want to take mechatronics, or CNC machining. And so I think we just got to start providing these opportunities for our youth at an earlier age. So one of the cool things I think is, a lot of elementary schools now, they're doing robotics program, which, even with welding and machining and like a lot of the skilled trade stuff, a lot of them are switching over to automation. So, we're getting younger kids, elementary school age, into using their hands. I mean, they're programming, so they're using their mind and their hands. The robot's doing all the work. But I would still consider that like a hands-on type industry. So now we're slowly shining a light back on it, but I still think, middle school, high school, we got to start focusing on welding and HVAC and electrical and like everything that makes this world go round.
Yeah. Otherwise we're going to stop.
Yeah. That's the sad part. I'm pretty, I'm hopeful that things will change a little bit. I see it moving in a good direction right now. So we'll see how it all pans out.
Yeah, I just wish schools here are starting to come a little more with the trades. I mean, the community college here where I went to just opened a huge tech center. We're getting heavy into welding now and all the other trades, which just surprised me. I didn't even know they're doing it. Just opened up this year, which is great. I just hope people take advantage of it.
Yeah, I see a lot of maker spaces popping up in different cities and stuff too, which is good because now you're starting to get people that they've got that interest. And, if the schools were smart, they would start recruiting in those areas and say, oh, you like to build stuff, you like working with your hands, well, check out this trades program. We'll get you a skill and, we'll help fund it through different grants and scholarships. And then once you get done, we'll help with employment. You can actually get a job building these widgets, for these high school kids that want to get into building things, start nurturing that interest at an earlier age.
Yeah, you can make a lot of money in the trades right now.
Yeah.
A lot of money.
Yeah, because they're hurting for good people.
Yeah. You just got to be willing to do it and learn it and stick with it.
100%. And the work ethics, like I said, that's a big one. That's what everybody's looking for.
Yep.
That's my buddy Ryan Eubank always says, show up, shut up, and do a good job. And once people
stay a while.
Yeah. Once people start realizing that, you'll go a lot further and more doors will start opening up for you.
Yeah, it seems like nobody wants to stay in the same job for more than 2 years now. It's like, oh, tired of this, want to do something else now.
Yep. Yeah, I think longevity went away a long time ago. My grandfather was big on that. He worked for the same company from the time he was 16 up until the time he retired. And he never understood, when I was a young kid, how I had, a job here for, a year or two and then a job here and then joined the military, got out and worked for a couple other different companies. And he was like, why don't you just find one company and stick with it? Well, I got to find a company that values me.
I think during his era, he was lucky he got a job and he was keeping it.
Yep, that's true. Yeah, it's definitely different nowadays. I mean, you don't find a whole lot of people that are working for the same company 20, 30 years. Yeah, it's different. Different employment opportunities nowadays.
Yeah.
Well, Rob, it's been a pleasure talking to you, man. I really appreciate you taking your time out of your day to come on here and joining us for Weld Wednesdays with AWS. It was awesome meeting you. Hopefully I'll run into you either, I don't know if you go to Fab Tech or anything like that or any of the other AWS events, but maybe I'll bump into you.
Yeah, hopefully, yeah. And I really appreciate you having me on. It was a pleasure. It was fun.
Thank you. All right, everyone, thank you so much for tuning into this week's episode. Be sure to check out new episodes of Weld Wednesdays with AWS the first Wednesday of every month. For more information on how you can get involved with AWS, check out aws.org. Hope you all enjoy the rest of your week. Stay safe out there, and until next time, make every weld better than your last.